open, one normally close, then one for motor. This is for start bus button, this is for stop bus button, this one motor. And now we have for a motor, there is one hold on contact is required to so that the motor will get continuous supply. So we will one block here. And this is the vertical or horizontal connection. Then we will have two indications. One is motor on indication and one is motor off indication. So we will use an yellow block here. It will give an output and one NC block. It will give one more output. Now we will give variables. New variable boolean. So the first one is start. So here you have to give a reference address, this type of input. This is discrete input or digital input. Now you can see it is assigned one number I1. Then we will create one more. It will give stop. This is also digital input, discrete input. So it is by default to 2. Now the motor, it is output. New variable boolean. The motor. This is discrete output or digital output. Now we see that motor is gone up. We want to, it should be, so here we will sort it by address, so that start stop motor is in sequence. Now here we will assign the it will start. This is motor. This is hold on contact for motor. Now this is the on indication. Motor on. We will give one more. Motor off. This one we will assign first motor on. This will be your output. it is already Q2. So now we make one more.
Now this is our board, electrical board for system, and this is our G connector PLC. Now we will power on. Now you can see the two LEDs glow. One is for power. If power is okay, it will give okay indication. If the everything hardware is okay, it will give okay indication. Then we run do the one more indication will come and run indication. So this is 16 input and 12 output PLC.
Before downloading the program, we have to validate it. So now we validate. The message is validating complete 0 value 0 message. Now we will go to online. Now the device is connected. Here you can see the Q3 output is on because the motor is off condition. So this is in motor off condition on. That one we can see in the PLC also.
Q3 is on. Q3 means motor off indication.
Now we will force the input. will force the start. Now you can see the motor current starts flow from here. This is NC button. This is hold and contact. The motor on and indication on. This one we can see in the controller also.
That we can see in the PLC, the Q3 is off and Q1, Q2 are on.
Now the motor is in running condition. So two indications are on, motor on and motor on. Now we will apply force on stop push button. Now see the current brake here, as the motor off, and the indication on, indication off, indication on. This one I can see in the controller also, PLC also.
Now you can see only Q3, means a motor off, indication is on. Good morning friends. In the last session we have seen the overview of our 1500 kV air control panel power diagram and the control diagram. Here there is one main incomer which is feeding to the copper bus bar systems. Bus bars are the copper flat bars. We use instead of wire, flexible wires due to some technical reasons. Then from the bus bar there will be one branch breaker Q1. It will be Q1 will feed to three set of contactors K1.1, K1.2, K1.3. Again one with each contactor will feed two capacitor banks parallel to each other. And here the 25 kVA, 25 kVA, total 50 kVA. Designation is 1C1 and 1C2. The second set is K1.2, and it is feeding to 1C3, 1C4, 50 kVA, 25 kVA guide. The third set is 1.3, it is feeding to 12.5 kVA each contactor capacitor banks. Designation is C1, C5, 1, C6. For the other branch circuit branches, we have the single line diagram form. The branch breakers are Q2 to Q12 and the contactor and the capacitors are designated accordingly. Coming to the control circuit, we have our 480 volt system. But since some components are wired onto the door, like push button pilot lights, this 480 volt cannot be used as a control voltage, because by some accidental contact, if you get somebody touch come in contact with any light parts, you will severely get shocked. So we have to reduce the voltage to a safe limit. So our control voltages are 230, 110, 48, 24, AC or DC, depending on the system requirement. So here we have one control transformer 480 to 30 volt. It is connected to phase, either RY or YB or BR. Then in the primary, there will be one fuse protecting the coil of this transparent contactor transformer. And secondary, there will be one fuse. So here the output will be 230 volt AC. This is phase and this is neutral for the control system. Now there will be one auto manual switch. In auto mode, when the switch turn to right auto mode, the power come to here and there will be one controller contact inside the controller. Depending on the signal, it will be switch on, either close or open. So when it close, the power come here and all the this contactor coils are get energized. So contactor is like a magnetic switch. When this coil gets supplied, it magnetic field forms and it holds a moving part. So one fixed part and moving part are get closed here. So and since there is a pilot light parallel to the coil, so it gives indication that the contactor is switched on. So obviously it is when the contactor switch on, the capacitor will be charged. So this PL1 when glow, it will be indication that capacitor bags are on. In manual mode, when switch is turned to left, the supply come here, then it pass through a stop push button or a open push button. It has a normally closed contact. Normally closed means in normal condition it will be this contact remains always closed condition. And this is one closing push button. This is normally open contact. These are all are spring operated. So when you press this, the contact current come here and come to the this contactor gets supply. But when you leave this switch push button, this contactor gets off. So to latch it, we are using one NO contact of this contactor as a latching. The function is like this. When you press this button, this energizes, and the auxiliary contact is some contact of it. It is some auxiliary contact. It closes when the coil gets supplied. This also closes, and now current carries this path and this path. So even when you leave this push button, the current continue in this path. So it remains in the closed condition. If you want to break the switch, break the path, you have to press this. If you press this, then this will not close automatically unless you press it. And there is a center of opposition, automatic switch of center of opposition. When you want to de-energize the system, if you don't want to operate in either auto or manual mode, you can put in center position. Or if you want to make some maintenance or repair work, you can put this in center position. For others the same principle, but here the switch is gang operated. When you turn the switch to manual mode, all the switches will be turned, all the contact will be changed to manual mode or auto mode. And here this is general representation for circuit PL2 to 12. So pilot lights are represented by PL2 to PL12. Now in the next chapter we will see the wiring diagram of the controller. This is a typical diagram of a controller. So here our supply voltage is 230 volt AC, control supply. Now this controller have options for 400 volt, 230 volt, 110 volt, and 0 is common. We have to apply the voltage depending upon availability. Then there is 2 points K and I. This is crucial because these 2 points receive the signal from the main panel, main system. Main system means suppose this is your main panel. It is feeding to blower, water pump, lift, lighting, workshop, exhaust fan, all the loads. So some loads are like blower, water pump, all are inductive loads. So depending upon the operation of these loads, the power factor, sorry, the current nature of the current is the lagging because of inductive load. So depending on the load, this will give these are the current transformers for metering of this panel, but there will be one fourth CT current transformer. This will feed to this point K and I. So this is a comparator. Inside there we have to put the target power factor 0.98 or 97 or 96, and the comparator will compare the nature of the power factor of the system, and it will give signal to close these contacts 1 to 12. So depending upon how many kVARs required, these contacts are closed or open. Suppose the load is some loads are switched off, then the power factor improves. So in that case, some capacitors are switched off automatically by this controller contacts. Here, this point A is for supply coming from here, because the current should pass through the contact and come to, this is a relay or contactor. Some cases, if the contactor size is small, it directly feeds the contactors, and if some cases, if the contactors are big size, or there are more than more contacts. Like in our case, we have 3 contactors in parallel. So the load comes to this point. In that case, this contact will burn, and since it is inside the contactor, we can repair it. In that case, so to avoid this, we are using one small relay. It will have only small auxiliary contacts, and this contact will not damage, and this yellow contact will energize the main contactor, the power contactors. This is called capacitor duty contactors, because there are many types of contactors, lighting contactor, for motor or switching contactor, but this is special type, so this is called CDC or capacitor duty contactors. Now in the next topic, we will see use of reactors, detune reactors. Okay. So this is the overview of our system. The left side upper portion is a power diagram. The lower side is control diagram. And right side is a controller diagram. And extreme right side is main panel. In the next topic, we will discuss about the detune reactors and the creation of filler metal for this panel. So this is the electrical equivalent of electrical diagram equivalent of logic. In our electrical diagram, we have an auto manual switch. So here, this is the auto. This is the manual. Now, when we close this auto manual position, one lamp is running, glowing. This is indicates the manual mode is on. And when we close this, when turn the switch to auto mode, this lamp is indicating auto mode. And in manual mode, we have seen we have now, this is our switch. When you turn this left, the contact block is this side. This is giving power go to this. But turn right, this auto mode is running. So always there will be either auto or manual. So here that one is represented by one interlock. Means if you try to close both switch, you see what happens. Now this is in manual mode, so one on,
and when this auto mode on, then I try to close it. When auto is on, I try to close this. You can see both the off because the current is blocking up to here. Red line means there is a blocking current. Blue means there is no current. So because of interlock between these two, the line is blocked here. Okay, then we have our push buttons. We have our manual mode. We have push buttons. We are represented by. So suppose we will put this in our manual mode. You will see all the manual modes are closed. Here one, this is a four-stage controller. So there will be four stage P1. Then here one second stage. This is third stage. And this is fourth stage. So you can see all the manual modes are on. Now we will switch on the capacitors one by one. Now this is manual mode. I will close this. So by push button, there is a one contactor in our electrical circuit. This electrical circuit, when we close this push button, this contactor vanishes, and because this contactor is closing one capacitor 10 kVA, 10 kVA. So this is our output. This is 10 kVA capacity switch on because of the first step. Now coming to second step. Now we will close this. So this again contact is closing contact K2. So our second capacitor is 15 kVA, which is switched on. Now coming to third stage. I am closing this. So contact closing. So contact closing the 20 kVA capacitor. So third capacitor is on. Now coming to fourth stage. This is the one. Closing K4 and it on. So now all the capacitors are in manual mode. Now I want to switch off one by one. So for that I will switch off this button off, fourth one, the third one, second one, first one. So this is the manual operation of the this button and contactor and capacitor. Now we will reset all. Now we will turn the switch into auto mode. So this is your auto mode. This is your auto mode. Now turn the color auto, and this is also showing auto mode. Now this is in our diagram. You can see there is a, these are the push buttons. When you press this, wire is considered here. This is spring operated. This will be closed momentarily, and this is one for this is one NO contactor. This is NC contactor. So these are on off. Then these are the contactors which control the which give supply to which give power to the capacitors. This is a special duty contactor called the capacitor contactors. These are the pilot lights. It indicates on or off indication. These are capacitors. Now this is the controller of the heart of the system. If you will see backside, there will be one switching devices. There are some switching devices. Depending on our requirement, these are these are give a signal to the contactors to open or close the contactors. So now in our system, we will consider this as auto contactor. One signal. Suppose the signal came to switch on one 10 kVA contactor, so this will close. This is control will give. Now you see this 10 kVA capacitor is on. Now suppose the demand requires more, so additional 15 kVA. So the second contactor will close from the controller. Now you see one 15 kVA capacitor is on now. Now is 25, 10 plus 15. Now still you need 20 kVA. So what you will do? This controller will give 20 kVA. Yes. Now this is a 10, 15, 20. 10 plus 15, 25 plus 20, 45. 45, then you need still 25. So this will close. Now all capacitors 10, 15, 10, sorry, 10, 15, 20 and 25 all around. Now suppose the some inductive loads are switched off like blower or pump or some lift, a switch of escalator. Then power factor improvement means suppose you need to reduce your capacitors one switch off. So here switch off is controlling C controller one. So this contact will open. Now still some further loads are closed, stopped. So we need to switch off on 50 kVA capacitor. So controller will give command to switch open this contact. Still you will need by this we can switch off automatically switch off all these contacts. So now only all are switched off. So this is the how the controller works.
ये एक एलईडी प्रोसेसर सर्किट है, इसमें एक बिजली को रेजिस्टेंस ये जो है एलईडी के कैपेसिटर को ज़्यादा कम करने के लिए, तो ये उसका एक्चुअल सिस्टम है। तो पहले हम सर्किट सिमुलेशन करेंगे, फिर बाद में इसको करेंगे। तो इसको हम तो पहले हम रेजिस्टेंस कम करेंगे। फिर ये रेजिस्टेंस से बढ़ाएंगे। स्लो हो रहा है। ये एक्चुअल सिस्टम है, ये उसका पार्ट है मेरे को रेजिस्टेंस के। अभी इसको फ्लैश रेट ज़्यादा हो रहा है, इसलिए ये पार्ट की वजह से लोएस्ट रेट है। हाईएस्ट रेट है। This is the circuit diagram and the light circuit diagram motor control system. In place of motor, here we have a bulb. These are the push button, start push button. We can start the motor. We can stop this red push button. And these are the indication lights. This green light indicate when motor run. This go. The red lamp go when motor off. And due to some reason, if motor draw heavy current, more current, this motor will trip. And this will give the yellow lamp glow. So now we start this motor by pressing this green button, and we can stop by pressing red button. If we want to run the motor or stop the motor from a remote location, like control room or control outside plant, this is the remote control station. So we can start and stop remotely. This is a lighting control panel. We can control a light or a group of lights by this panel. It has two modes, manual and auto. In manual mode, we can turn to manual position the switch, it will go. In auto mode, it will be controlled by this sensor, dark and light sensor, also known as photocell. So now we will turn to auto mode. After sensing light, we switch off the bulb. Now we will make our system dark. After sensing dark, it is switch on the light. It is mostly used in street light application. In the evening, the system will switch on the street lights. In the morning, it will be switch off the lights automatically due to this sensor. Now it switch off due to light. Now this is called programmable logic controller. It is used for automation systems. Now the switch is manual auto switch. Now when we put this switch in auto mode, this motor or bulb will be controlled by this PLC. So it will be there is a sensor here. The sensor is connected to a relay. The relay will give signal to the PLC, and the PLC will switch on this light. Now due to presence of light, we switch off. Now we will make our system dark. After sensing dark, it switch on the light. Now here, this relay was before not activated. After getting a signal, the relay activated, it will give signal to the PLC, and PLC give switch on the light. This is how an automation system works. So now we will have a little comparison. It will be conventional system and automation system. In this conventional system, the sensor is directly connected to a panel. But in automation system, these sensors are connected in the field, and from field signals come to activate a relay. Now the relay is in off condition. When we switch off the light, we will get a signal from the field. Now the relay is activated and this signal is processed. So in an automation system like this, lot of parameters we can control. If you want to control temperature, we can connect a signal to this relay. And if you want to control a pump, which is filling an overhead tank, when the overhead tank fill, it can stop the motor from this PLC. If the underground tank is become empty, it can stop the motor to prevent dry run. It can control humidity. So many things can be controlled by PLC. Thank you. And discussed this is known as the program logic controller or PLC, which is the heart of the system. The first module is called CPU, Central Processing Unit, like computer. It processes the data. And the second one is extension module. There are two types of input output. One is digital and another is analog. When we need only switch on, switch off function, we use analog input, analog output. This first unit consists of CPU and I/O, digital I/O, and the second unit is analog I/O. So this when we need continuous monitoring temperature, pressure, or humidity, we connect the data here. These PLC also have many ports for networking, Ethernet port, Modbus, Profibus, all this, so that that it can be, the data can be communicated to different departments and different systems. This is a typical SCADA screen. SCADA means supervisory control and data acquisition. In this screen, every equipment in the plant, graphic made to be for each equipment in the plant, and there will be sensors in the plant. We have to take the data. So here we can see the actual monitoring system. This is a small program for motor control. This is our motor stop condition. This is lamp glow. This is motor stop condition. Now from soft switch, from SCADA button, these are SCADA buttons. We can start this from this here. So after this, the motor starts running. This is your motor rolling indication. Now if you will switch off, it will stop here. Now this is motor stop indication giving. We can start from here again. In case motor overload, motor stop and also give trip indication. So this is it. A small example of SCADA screen. Thank you. What are the introduction myself to the projects. This is basically for the skill development. We have two sections. One is industrial training and education standard. This is very basic level. Will be suitable for those who want to work with electrical, welding, electrical, industrial equipment, draftsman, computer, etc. There is a high option with electrical control and automation training. It is the urban level people. So this is we are going to start a we are going to give a particular electrical 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 control panel. Control panel is like anything that control system like car, bike, accelerator, brake, control, gear control device. So by using we are controlling here electrical system also controlled by the device. Therefore, if we can't control, we know what happens. The worst thing is just like it is soft, little soft, learning surface. Okay, now this is our product. Now I'm going to show you a 3D view of our product. So this is our 3D view product. You can rotate it in any position. So now let us give some part identification. Now this is the biggest one. It's called digital air circuit breaker or in short ACB. Then this is called the border case circuit breaker or in ACB. Okay. Then the smallest one is called miniature circuit breaker, popularly known to MCB. Now here in connection, you can see how this one power your cable will connect from doctor side. Then this is a switch, big switch. taking the medicine. It will go to the current flows through a upper or aluminum glass, glass. Here there is some thickness here. You can see. You can see there is some thickness here. Maybe 10 mm or something. So the power transfer from the power starts from here. Then it go to a distributed system. This one then it comes down. Then here again goes to the branches. This is the branches. This is the main. It is the branch branch. Simple main. Implement. These are called branches. Of the branches. And these are called sub branches. Why it is called sub branches? If you will see back side, this breaker is pointed to the direct cable connection outside. But this breaker goes to the back side of it. It is the back side. Going to back side. Then there is a called one more distributed system. And from again here, power to access to this many LCDs. So this is called the sub branches. Our electrical diagram. This is our electrical diagram of the system. You can see one informer going to here. Same thing we have the electrical. This is called the informer. This is the outgoing one. This is called outgoing to the zone. This take to control zone. Coming back to our now we will so this is we have shown in our slide that this is a product inverse mechanical electrical instrument. So we will start also mechanical first. Other two numbers. Now this is dimension. This dimension important. This is 1000 height, 1 meter height, and there is one more chamber distribution.
This one is called reservoir chamber. How it is kept in a separate place. Very different. Because nobody will be open this chamber. Only 25% open this will be open only this area only. If you want to see something, even this field there will be a door in this. I will not show you. There is a door on it. It will open to the door close to this one. But if somebody want to see something, we will open, allow to see open this area. This will be closed by like a door, a huge door. So you can go open. But this chamber is always open open. Like the church, it is highly high risk. All these are life also. Even this
Just
is
for
also
deviation
coconut.
for
This is why we coconut. If you open, you cannot see. It's just that. Right, so let us start with one member. This member. In our drawing, it is 1000, but for workshop purpose, I will split it into actually the 500, 500. So this is our 500 part. This is basically a angle of 35 mm 1 inch or 30 mm. And length is of 500 mm. Now we will make it 130 mm. How so for that we will add we have several things in high condition. To make this joint function, you need to make a bracket here, small bracket. One side will hold weld here. And one side will be a welding inside, it will be one hole here. Then we need one more same piece. So now you can see it is now the unit of there will be two brackets this side. And there will be vertical for floating. So now we got one frame. Now like this. Now suppose we need one more vertical frame outside. Okay. We are trying to do by animation. Now now we will need one more this here and one more here. Okay. This is the front side and this is your actual step. Now regarding this dimension of how much this is. Because your dimension is your 600 mm. So and one frame size is 25 mm frame. So to make 200 or 200, you will need this frame. This frame should be this 25 is our this side plus 850 plus 25. This will be 250, 550 ml. With 550 ml. Because here we will have 50 ml. Here also will be 50 ml. Again. तो हमें लगभग आइडिया कितना हो यहाँ हो 350 मिल गया इधर से 25 ml दिया पर ऊपर वाले से दिया हो 30 of the same आंसर पड़ता है 350 अपने नाव के दूसरे তারপরে আমি টাইপড একটা ভার্টিক্যাল দাও তো সেম সাইজ দাও বর্তমান দেখলাম যে আমরা একটু সেকশন একটু হবে অ্যাড করুন অপশন আছে Now we go for a practical number. You can see there are the atomic parts here. 1, 2, 3, 4, 5, 6, 7, 8. So 4 verticals. 1, 2, 3, 4, 4 horizontals. And this is 1, and this is 1. Now I am going to question the question. How much angle is required to make this?